Okay, welcome to February 13th, 2025, ELEC 1013 Network Cabling Class. Lecture today, it's the second part of, POTS, USOC, and 25 pair color code. First thing I'm going to show you is, where do I have it? Yes, I do have it here. I multi-simmed the way the telephone rings. Right? It's just what I call this thing, telephone line POTS, voltages simplified. POTS, as we remember, it stands for plain old telephone service. Right? It is the most basic telephone line delivery that you can get these days, the year 2025. Still. All right. Now, just as a recap, can I? Yeah, all right. Yes, I can. When we're talking about the telephone lines, the pairs, because in telecommunications, we don't say that we're dealing with the positive wire and the negative wire or things like that. We're talking about pairs. Why? Because in POTS, plain old telephone service, one pair, well, for the most part, usually, one pair, in the POTS signal, yes, it's always. In the POTS signal, there's one pair designated per one conversation. One pair of what? One pair of wires. So, we're dealing with the lab this week, the 2025 network cabling course, that we're connecting a 25 pair cable onto something that's called a BIX terminal. So 25 pair cable can carry 25 separate, simultaneously 25 telephone conversations, because one pair of conductors, one pair, is designated for one telephone conversation. Okay. Now, how is it that we are wiring things? Each pair, now to make things even nicer and funnier, not funnier, but I'm introducing you to certain terminology. In the old days, you're talking 1930s, right? The telephone number selection was not automatic as it is now. You dial the number, and there is some sort of automatic electronic circuitry that is going to connect you to to that phone. Is going to connect your phone to the phone of that specific number. Right? So, before the automation was introduced, before the dial tone was introduced, and the dial tone came with the rotary dial type of a telephone. Before that, there was human interaction. You pick up the phone, and you don't hear the dial tone. Well, you don't hear the dial tone now when you use your cell phones. However, if you're using the so-called landline, POTS line, plain old telephone service, you pick up the phone, put it to your ear, and you hear the dial tone. Yeah. You can break the dial tone in two ways. One, by the rotary dial, which you don't see that anymore, but the phone system, the central offices, is the electronics that is connected to the line, is going to understand the rotary dial type of a tone breaking initiation. Because you can still program the phone systems into dialing DTMF or the rotary. Rotary dial basically breaks the line. It just interrupts the line to whatever number you're dialing. So number 3 would be 3 interruptions. Number 4 would be 4 interruptions. And the number would be selected by this means. Now, DTMF, dual tone multi-frequency, DTMF, it's basically tone dialing. Right? Dual tone is introducing 2 tones in order to break the dial tone first and then just keep dialing the number. Once you break the dial tone, the first number is being recognized by the electronics. Why do we need 2 tones? Well, if it was just a single tone representing a number, you pick up the phone, there could be a TV going in the background or a radio or people talking, and any kind of sound that is in the background could be mistaken for a number because the circuitry is listening. So in order for that not to happen, a dual tone. So every number has 2 specific frequency tones assigned. And then once those 2 frequencies are present, then that sound made by those 2 frequencies is going to be recognized as a number. But before that, way before that, you pick up the phone and you would not hear a dial tone. You would hear a human saying to you, "Number, please." It was that famous saying that, well, you don't hear that anymore. Well, even I, with the years that I have, never heard that because it was way, I was born way past that. Okay? But you would hear "Number, please." And those ladies who were sitting there at those switchboards, huge switchboards, they would use those right here, all right, those 1/4 inch, because there's a 1/4 inch diameter, jacks or plugs to patch you to the certain person. So if there was a small town in the beginning, well, you could just probably say that, "Can you connect me to Mrs. Smith?" Right? And they would know where Mrs. Smith's phone jack was on that small switchboard that they had, because phones are not popular at the beginning. If there were bigger cities like New York or Chicago or whatnot, then you would have to tell them the number, and they would patch you through that. And after you hang up, there would be certain lights going on or off that the conversation has to be disconnected and so on. So those jacks, same as, if there are any guitar players or musicians in our class, excuse me, you will recognize this type of a plug. It's a 1/4 inch plug, which has a tip right here, and it has a ring. And sometimes it will have a tip, ring, and sleeve, depending whether you want to carry a balanced or unbalanced signal. And maybe we can talk about that too. But for just plus and minus or tip and ring, you're going to have that sleeve eliminated. So this here would be just one piece, and it would not have 3 connections to it. It would just have 2 connections. Otherwise, TRS, tip, ring, sleeve, phone plug. Right. Now, how does that translate into the modern communications? Is just a review from the first part. Here's a jack, telephone jack, RJ12 or RJ11. RJ stands for registered jack because things have to be standardized. And the J stands for jack, so RJ. And 11 or 12 or 21 or RJ45, these are just, those numbers are cataloging numbers. So you can treat those numbers as like names. Right? So here's the RJ12 because it has 1, 2, 3 pair capabilities. See that? So it's 6 of them. RJ12. RJ11 is the same shape, except those two prongs will be empty. There will be no prongs there, just capable of 2 pairs. Usually, those are being used to connect 1 pair, even though the jack's capability is to connect more than 1 pair. And where does that 1 pair, or pair number 1, tip and ring, live? It lives in the 2 middle prongs. That's where we look for the signal for POTS, plain old telephone service. You can see that here. Tip and ring 1. That's the first pair if there was only 1 telephone line connected to it. If there was some sort of a switchboard or a specific type of phone that you could switch between lines, and in early 80s or mid 80s, those phones were still being used. It was just a clank type of a switch on the phone, and you could switch between lines, and you could connect it with just 1 telephone cord. So that would be a second pair connected to the, so the pairs in the USOC configuration. USOC stands for Universal Service Ordering Code. It's a mouthful. However, it is it's the way things are being wired. Okay. So, how do we count the pairs as opposed to counting the pins? If you're looking straight into the jack, the pins would be counted 1, 2, 3, 4, 5, 6, like just from left to right. Okay. If you hear that noise in the background, it's somebody's doing the snow blowing. It's winter, in the middle of the winter. The beauty of the winter. Canadian, okay, whatever. So how do we count the pairs as opposed to pins? The pairs we count from the middle outwards. So here's pair 1, here's pair 2, here's pair 3. This is not how we count the pairs in RJ45 or Ethernet connection, but we already have done that. USOC, the pairs are they just keep going outwards. Right? And here are the colors of the wires. Tip is green for the first pair, and the ring is connected. So even though we are not using those jacks anymore, those those phone plugs in telephony, because everything is done automatic, we still, that terminology kind of carried over the years and it was kept. So with the telephone line, we call it tip and ring. It's just the way it stayed, all right? Now, how is it that the telephone line rings? This is a very simplified, I multi-simmed it, right? It's a very, quite simplified connection just to picturize, just to show you the way that the ring voltage is introduced to the line. Normally, a phone line, the jack here, where are we? If this is just one phone line, the only pair in the middle would be energized, and it is idling at negative 45 volts DC, constantly having there. Minus 45 volts. Why do I say minus 45? It's because the tip is more positive than the ring. Forget the sleeve, okay? But the tip is connected to the ground. So the ring is negative with reference to the tip, and it means it's negative with reference to ground. Look at how things are connected here. Here's the battery. So here's another terminology that I'm introducing you to, is that when you are troubleshooting a line, telephone line, you're looking for two things. You're looking for dial tone, and you're looking for the battery. The battery means that there's 48 volts between those two lines, between tip and ring. And a dial tone is like, listen to it. Now, when you're having those DSL lines or dry loops, which means there's a telephone line introducing just an internet signal, things are getting a little bit more complicated, because then we're dealing with dry loops. Sometimes people don't want to have a landline, but they still want to have the internet through the phone line. So there's no dial tone. There will be battery present or not, but there will be just DSL signal present on it. With DSL stands for digital subscribers line, which is basically internet over the phone. But we're not talking about the DSL right now. We're talking just the phones. So we're looking for, is the battery present, which negative 48 volts DC, and is there dial tone? If one of them is missing, then then some of the circuitry maybe needs to be reset. But that's on the central office part, on the city part, from the city side, not from the city, but from where the city is. Usually in our area will be Bell Telephone, Bell Canada. Right? In the States will be AT&T. In western provinces of Canada there would be TELUS and so on. Now, look how we are. Oops. Yeah. I also use the colors of the tip and ring. See here, tip. The first pair is green and red. Second pair is black and yellow. And the third pair would be white and blue if there were three pairs. That's the old color code. You can still see that. The new color code is because we can use the Ethernet cable, 4 pairs, to carry the phone pairs. And the Ethernet cable has 4 pairs, blue, orange, green, brown. And if we just use the 3 pairs, we're just going to use blue, orange, green, and we're just going to ignore the brown pair. So that's how things translate to things. So you're going to have a solid blue as the ring, and you're going to have the green tip as the stripe. You can connect other things in a different way, but I'm going to explain it to you later. Now, how is it that the phone rings? At the jack, as I said, there is that idle minus 48 volts DC just sitting there. Okay, so let's scope it. I multi-simmed it, put it on the scope. So let's turn the scope on here. And do we have it turned on? Yes, now we have it turned on. Now, over here is the battery that is basically provided by the central office, which is the building where all the automated circuitry is for the phones. And with the switch, we're just going to turn that on. Now we're going to bypass whatever this is here. Just going to bypass that for now. And we're going to have this here. Here's a tip and ring. And I made it green and red here, okay, just to kind of make things neat. And this 1 kilo ohm resistor, that's our telephone. Okay. So let's see what we have when we start the simulation. And we introduce the voltages. Now, over here, I moved. See here, if I look at the position, I can move my 0 reference. And I moved it from the middle of the screen. I moved it up here because we're going to deal with negative voltages. So let's make the reference somewhere on the top. Okay, so let's introduce negative 48 volts, and now we have channel 1 here, which is displayed. We have 20 volts per division, so each square is representing 20 volts. So negative 48 is going to be 20, 40, somewhere here. Okay, let's see. Turn the switch on. All right, there you go. There we go. Now, that's how the phone line idles. Sip of coffee, clear my throat. Now, when the phone rings, here is another generator in series. I'm just simplifying things, which generates 90 volts peak to peak. All right. How is it 90 volts peak to peak? Just as a reminder, here's our x-axis, here's our y-axis, here's our sine wave, here is 90 volts peak to peak. All right, 90 volts. All right. So that's what this thing is giving us, 90 volts peak to peak at 20 hertz. Why is it 20 hertz? Because in the old times when things were ringing, there would be those two bells. Let me see here. There'll be one bell, there'll be another bell mounted on a piece of wood, and there would be that electromagnetic, well, there's going to be some sort of electromagnet here with the little hammer here. And the electromagnet would be powered up with 20 hertz, so this hammer would hit those two bells 20 times per second at 20 hertz, and you would hear that classic old telephone ring. It comes from something that was real. So the 20 hertz stayed there. Let's see what's going to happen with the scope. Well, we have that negative 48 because you see here, the tip is sitting at the ground level, and it's the positive side of the battery. So the positive is sitting at the ground. Then the 48 volts the battery has, the ring is negative with reference to the ground. So even more negative than the ground. Right? So once we introduce that 90 volts peak to peak 20 hertz, we're going to see that waveform on that, riding on that negative 48 volts. Let's see here. Introduce the ring. So now the phone rings. Ring, all right? Not ring. Ring, not ring, okay? But notice here is negative 48 volts, and the middle of the sine wave is actually sitting at negative 48 volts. Right, so that's how the phone rings. 90 volts peak to peak, riding at negative 48 volts DC. So that's how the phone rings. Right? Let me just turn off the simulation so I'm not overloading my microprocessor. All right. There we go. So this is how things are happening here. Here's the jack. Here's the diagram of things. That's going to be in your post-it notes. All right, USOC stands for Universal Service Ordering Code. And here is a typical RJ11 telephone jack. Here's a jack. Here's a plug. This one is actually a splitter. Now, is this RJ11? Yes, RJ11. You see it has 1, 2, 3, 4 prongs, and the two outside are just empty slots. That's RJ11 registered jack 11 because things had to be standardized. So everybody connects things the same way. And if there were two more prongs here, it would be called RJ12. Now, user configuration, we just talked about that. Telephone jack. This is a typical surface mount telephone jack. And this one here is capable of 2 pairs. However, usually right now, if you have it, you're connecting only 1 pair, and it's going to be the one in the middle. Now, pay attention to this right now, because I'm just going to call up my board. Pay close attention to this now. This is important. It's going to be part of our lab, maybe after this. I'm not sure. Let's say you have a cable, Ethernet cable with 4 pairs. I'm just drawing 1 line per pair. So over here, we have a blue pair. Here we have orange pair. Here we have green pair. And here we have a brown pair. Now that, let's say, is extended from some sort of a main telephone connection demarcation point, which stands for point of entry. And let's say we are going to get 2 lines connected. Okay. So over here, let's say we're going to use the blue pair, and we're going to use the orange pair, which basically has, each pair has tip and ring, right? Every pair has tip and ring, right? Now, let's say telephone line 1 is going to be connected to the blue pair, and let's say line 2 is going to be connected to the orange pair. And these two here, green and brown, are just going to be ignored, so those are going to be just ignored here. This cable is capable of delivering 4 telephone lines. We're going to connect 2. That's the service call order was for, right? Let's say. Now, remember when we're dealing with the jack that has, let's say, RJ11 only has 4 prongs. Remember I said that the line, telephone line, the telephone jack that is connected to the telephone, right, is going to be looking for the signal in the 2 middle prongs. Right? Okay. Now, let's say we have 2 RJ45 jacks, and RJ45 jack is the ones that we already connected when we did the 110 punch down lab. Remember, the jack would have blue, orange, green, brown. And remember that the blue pair was always in the middle, 2 prongs. So we were doing that dance, blue, orange, and then green, and then brown. Remember that? So here's the blue, right here, 2 middle prongs. Okay. And the way things are made is that RG45 is able to physically accept that RJ 12 or 11 plug. You can actually plug in a telephone cord into a data jack. It physically will accept that. So, since the phone is looking for the signal in the two middle prongs, we're going to have to connect things to the two middle prongs. So, we have RG45 jack here, data jack basically, which has a blue, orange, green, and brown. And the phone is looking for the signal at the two middle prongs, and blue is connected, blue pair on the jack. All right. Blue pair on the jack is connected to the two middle prongs. Right. Then we're going to have to connect that to the blue pair. So if we plug in the phone cord, we're going to find the signal on the two middle prongs. So line 1 is going through this line here, this pair goes through the wire and is connected to the two middle prongs to the blue. Okay. Now we have the second line that also has to be connected to another jack that also has blue, orange, green, and brown. And there's a RG45 jack. Since this is to be just a regular POTS telephone line, we plug in the phone cord. That phone cord is still going to be looking for the signal nowhere else but at the two middle prongs to which the blue terminal is connected. So even though you are connecting the line 2 to the orange pair and it's connected all the way through and comes out the other end, in order for us to convey a phone signal onto this jack, that orange pair still has to be connected to the blue pair of this jack, because that's where the phone cord is going to be looking for the signal. I want you to understand that concept. No matter what color, if you're connecting just regular phone lines, one pair for each phone line, it doesn't matter what color the line is using, the jack has to use the blue pair if it's just for the phone. Right? I will ask you that on the test. Not this, well, maybe this one. Who knows? But it will be on the test. But we also are going to reinforce that knowledge by doing a lab, by connecting things a certain way. All right, go back here. Boom. So this is the old color code. The first is kind of drawn not accurately, but the red and green are going to the two middle prongs, and the black and yellow going outside here. So if this was just a really single line telephone that we're connecting, you'll be connecting just the red and green signal. Now, polarity matters. However, every phone right now has something that's called a bridge rectifier. I will strongly encourage you, if you haven't studied that yet, study something that's called a bridge rectifier. Bridge rectifier basically turns everything into the polarity that you want. So if you reverse the polarity on one side, it's going to give you the correct polarity on the other side after the bridge rectifier. And that's all I'm going to say about that right now. So the phones can forgive you if you misconnect the polarity. Other things might not, like paging interfaces and so on that we're going to talk about later on. They will not. You have to have the correct polarity. You have to connect the tip to the tip, and you have to connect ring to the ring. All right, here is another translation of how the old code, color code, translates into the new, well, the blue, orange, green, brown pairs. Right, if we're connecting that. However, remember that two middle prongs, depending on how you want to connect things, you have to think, okay? Now, here's the demarcation point, point of entry. A box sometimes could be mounted on the outside of the house or inside of the house. Here's a tip and ring. Here's a tip and ring. This one is capable of two lines the way it's configured right now. This is a lightning protection. This looks like it's a plastic PVC, but it's a specifically formulated composition of material that when the lightning hits, that is going to conduct current and it's going to take it right to the ground. So this part here is lightning protection. And you can see here there's a pair of wires, and here there's a pair of wires connecting things to this jack. This one connects things to this jack. You can plug that in to activate these two tip and ring here, or this tip and ring, and from here on the wire goes to the inside of the house. That's how this one works. All right, here we have a typical demarcation point. There are a couple of things here. What do we have here? Here's the BICS frame that we're using during our lab this week. Here's another BICS frame with, this one has BICS connectors, 25 pairs, 25 pairs, 25 pairs, 25 pairs. These all together give you 100 pairs. This is a 100 pair cable. So you get 25 pairs terminated here, 25 pairs, and so on. Now, after you terminate that, you flip it out around so the terminated wire is at the back of the connector, and you can use the cross-connect wires to grab the connection from the front and cross-connect that anywhere that things need to be connected. So this would be a field wiring here, for example. And this, those wires can be going to a shoe store in the mall, to a barber shop in the mall, and whatnot. So you'll be telephone lines coming in. And over here, if you open that box, which if you don't work for the telephone company, you shouldn't. You'll be the authorized technicians. Well, you could be one of them. You activate those lines by pressing a button from 1 to 100. Of course, it physically has to be connected on the other side in the well, on the street or in the central office building. This one here is a T1 connection. It's a modem. I wonder if we're going to talk about this here or not. T1 is a specific type of connection that over two pairs you can multiplex and have well, sort of like a broadband type of connection, mini broadband. You can have multiple phone lines modulated into different channels. One pair is a transmit, one pair is a receive. You connect that, and it splits into, I'm not sure, whatever the T1, and there is T1 in North America and E1 in Europe or in Asia and India. Multiple conversations, and one of those slides is specifically showing us the details, and I just don't remember which, how many, but we'll get to that, right? So that's what a T1 looks like because we're in North America. It's a modem, right? On one side of the modem, there are two pairs going to the central office, and on that two pairs, there's about 6 or 10 telephone lines simulated, and they are broken out into these BICs here, BICs frames. So there will be physical multi-lines here out of those two pairs, and so here also. Okay, it's less and less being used, this system, but still, because right now fiber optics are prying everything out. Right, pods and filtering. How are we doing here? We're doing good with time. Plain old telephone service filtering, related terminology, DSL, dry loop, voice. DSL stands for Digital Subscribers Line, which is the internet superimposed onto the phone line. So you get two signals over the one pair delivered to your house. One is the landline telephone, and on top of that there's superimposed signal, the internet signal, which sounds like a really annoying buzz if you're talking on the phone. So things need to be filtered out and directed to appropriate devices. Now, dry loop is a type of installation that involves regular telephone line with the internet signal present on the telephone line, the DSL signal present, but the voice circuitry is disconnected, so there won't be any dial tone. Because some people don't want to pay for the landline, since everybody in the family has cell phone right now these days. It wasn't like that before. Here's a filter that can be connected to each and individual phone. At each and individual phone location. So it filters out the DSL signal, annoying buzz, and only passes through the voice signal. So it's a low pass filter because that's a high frequency buzz. So now you can talk on the phone and not having to listen to the DSL signal present. So you can connect that into each individual phone. Or you can connect that at the beginning, this filter here, you can connect that at the point of entry to the house. So you can connect the telephone line to either the jack or the screw terminals. If you don't have the jack, you can just connect the wires straight into that. You can choose either or, they're interconnected. So that's where the line comes in. And from here, the circuitry just splits the signal, and it will send the voice into this jack, the voice signal into this jack, and it will send the DSL, Digital Subscribers Line, internet only, into this jack right here. So this is where you connect the modem, and this is you connect all the phones in the rest of the house. So you can have that one main filter at the demarcation point, which is point of entry, or you can have these installed at every single jack where there's a phone. Right? The terminology here, again, the phone line with no voice circuitry, no telephone connection, just a DSL signal, is called a dry loop, not to be confused with something that's called a hard loop. Okay. Here's the difference between dry loop and a hard loop. Here's the phone jack, here's the pods filter, and let's say here the modem signal is going to be connected to the modem, and the voice or phone is going to be connected to the rest of the phones. However, with the dry loop, you don't get the phone, you just get the internet signal. So you can connect that straight into the modem because you're not using phones. And from the other side of the modem, things are getting connected to the PCs and so on. Now, here is a hard loop. Both of them are called loops. This is a Cat5e hard loop because in Cat5e only two pairs are being used, orange and green. One is a transmit pair and the other one is a receive pair. Which is which? Well, it depends on which end of the cable you're looking at. So since one is transmit, one is receive, you can just connect the two solid ones, solid green and solid orange together, and stripe green and stripe orange, you just connect them together. So at that jack location, you are looping things. You're connecting the transmit pair into the receive pair. And you plug that in, and that is used for diagnostic purposes. You would not do that just on your own and do things, but if the line has to be diagnosed, the DSL line or T1 line has to be diagnosed, then you will plug things in and you will be on the phone with whatever the support person of whatever the company is providing the signal, and you plug in that loop, hard loop, let them do their testing, and they will tell you, okay, you can unplug this hard loop now, and then you can connect the rest of the circuitry as it was. The testing is done. So this is just for the diagnostic purposes. What am I doing here? All right, cool. Yeah, we get the bird. Now, again, we're approaching that 10-2, so I'm going to keep going. If you have to go, by all means go, and you can catch that catch the end of this lecture when I post it on the YouTube, which is going to be a few minutes from now, right? But I'm going to go a couple minutes over. Wiring configuration for the phones. This used to be the old ways of connecting the phones. It was called the daisy chain way. You would get the phone line from the outside, going through the demarcation point, which is point of entry, and you would connect that into the first jack, and then you would parallel connect it to another jack and another jack, whichever amount of jacks the telephone company would allow you to or suggest, so the system is not loaded too much. We don't do that anymore. First of all, we don't use the phone cable for phones anymore. We just use the data cable. But the phone jacks, all the phone jacks, we can connect with the data cable, and we can connect in a T568 A or B, which we already connected that. And we're going to connect that in a star configuration. So from every phone jack in the house, there's a dedicated wire that goes to that central point. And if you use the Cat5e or Cat6 wire, then that jack can be used as either phone jack or a data jack, because you already have the data connection wired in T568, not in a USOC configuration, but since you want to use the phone, pair blue, which is pair 1, which is the two middle prongs, still is wired to pair blue. So if you connect a phone signal on one end, that phone signal is going to be conveyed right to the jack where it is. So that's how we connect things now. We just basically connect phone jacks just as data jacks, because in that case, and we run them in a star configuration, star topology, so now each jack can be used as data or phone if you have well, if you want to use it one way or the other. 25 pair color code. I got a couple minutes to show it to you, and I will. Some of us already know. That's what a 25 pair cable looks like. It has 25 pairs, 50 conductors. Each pair is going to have a twist. It's going to be twisted together. And of course, the reason for the twist is to eliminate crosstalk. Now, here is cut 3. You see that there is a bit of a twist, but not as much. And usually with the 25 pair cable, you're going to see cut 3 cable, which is the telephone cable. There are some cut 5, cut 5E, or cut 6 25 pair cables, but they're not being used as much. However, you might encounter a situation that you're going to have to use one of those. You can see the twist is much tighter on those. That's the 25 pairs. The color code is, you have 5 groups. Here is group 1, group 2, 3, 4, and 5. Each of the 5 groups has 5 designation colors, and we remember those already: blue, orange, green, brown, and the 5th one is slate, which stands for gray. So if you got 5 groups, each has 5 designations. 5 times 5 gives us 25 pairs. Okay. Now, this we remember, and this repeats. Every group has blue, orange, green, brown, slate. Blue, orange, green, brown, slate, and so on. See that? This repeats for every group. Groups. How do you remember a group? The group colors. Well, the first one we already have dealt with, because you have blue, white, blue, orange, white, blue, white, orange, white, green, white, brown, white, slate, or we just deal with the 4 pairs with the Cat 5E cables that we used. So you know that the first group is white. Now here, this is how we're going to remember that. Then you go with the Canadian colors, and I feel so sorry for the people who live in Sweden, right? Because they can't use that scheme, right? They just have to remember the next color is red. But here, Canadian colors, we're in Canada, use the Canadian colors. Well, the next group color is red. Now here, we move from Canada right down to Texas. There are a couple of snakes. That one of them is called coral snake, and the other one is called scarlet snake. The coral snake is extremely poisonous. The coral snake is an imposter that wants to look like the other one, but it's not poisonous. So the coral snake has it has a large black ring with the yellow sides. So in order for the kids to be safe, there's a rhyme thing that is being taught to the kids in Texas or the southern states to stay away from those snakes, to distinguish one from the other. And when they say black and yellow killed a fellow, black and yellow killed a fellow. When they see those black and yellow in specific order, colors, then they have to stay away from those snakes. It just helps the kids to kind of stay safe. That's the rhyme that's being taught down in the southern states. So here, white is the first color, Canadian colors. Next one is red. Then we got black and yellow killed a fellow. And we have the violet, which sounds like violence. And violence is the last thing we need, and it's the last group. White, red, black and yellow kill a fellow. Violence is the last thing that we need. So if you want to, for example, find pair 18, what will be the colors? right? So pair 18, 5, 10, 15, 16, 17, 18. Here's yellow and green. That, if you remember those groups and if you remember those designation colors, you can tell that without even looking at the picture. 25 pair color cable is made into 25 pairs jacketed in one single jacket, and there's a bit of a ribbon. One is the wraparound ribbon that just kind of binds them sort of together, and the other one is going to have a ripcord just to rip the jacket. Now here's a 100 pair cable. 100 pair cable contains 4 25 pair cables in one jacket. But the 4 25 pair cables, they are the same. They have the same colors, same color codes. So how do we distinguish one bundle from another? By using the ribbons. Look, here is a ribbon, wraparound ribbon, and it's kind of like almost like a tape, but sometimes it's just a string of that color. Here's the blue, so that would be the first 25 pair. The next one here is going to have an orange ribbon. Then the third bundle is going to have a green ribbon, and the fourth pair is going to have a brown ribbon. So when you strip the jacket, you need to make sure that you grab as much the stripped length, and you have to make sure that you carefully peel off those ribbons and you tie those ribbons around each bundle, just to make sure that you don't lose the count of the bundles. Because if you just don't tie the knots around the bundles with the ribbons, you let everything go, everything's going to mix with it. Those pairs are going to mix with each other, and you will not know whether that white and green pair is from the first bundle or from the third bundle. So that's how the 100 pair cable is being solved. Applications, example number 1, multi-pair telecommunications, usually in telephony. This is how things are being terminated, and we'll show that during the lab. Here is a bunch of 25 pair cables. So one of those wafers, or 25 pair connectors, BICs, these are the BICs connectors, is capable of connecting 25 pairs. You terminate that here, you punch down and you flip it around so that cable here is connected at the back, and from the front we have clean connectors here that we could use something that's called a cross connect wire, that we can connect that pair to wherever it needs to go somewhere else. And that's, so here is the one frame, here's another frame, here's something called a cross connect cable. And cross connect cable is one, like this looks like a yellow and blue, but sometimes you just have different, white and blue or whatever. They're on like separate reels that you can just pack it in your bag. Or if you just in a pinch, and if you don't have the cross connect wire with you, you can just strip one wire cable and just grab one pair out of it and use it as a cross connect wire. Telephony. Here is something that's called RJ21, and here's X. X stands for male or female. All right, one part of it is male, one part of it, they plug into each other. So here's a little telephone system that has a bunch of connections. And you plug in that 25 pair cable that is terminated onto that RJ21 connector, and that is broken out into the BICs. So you can do the cross connecting just like that. Okay. And here are the references, and that's pretty much it for the. Now this is a small telephone system. It's capable of 3 by 8. Look, 3 telephone lines in, and you can have the first 8 of those are going to be extensions. So it's capable of 8 extensions. Then there's going to be a bunch of nothing, nothing, nothing. And I think the last one is going to be the music on hold connection. And there's going to be some relays or dry contacts. Now, this is a 3x8. Then there's some other ones that are called 616. So you're going to have 6 in, capable of 6 telephone lines and 16 extensions. And you can also have modular phones, but we're going to talk about that next time. We'll talk about the conventional telephone systems. Some of the modular phones that they don't use the telephone jacks for the lines, they use also the bigs because well, things are going to be expanded a little bit further. But that's as far as the second part of the pods, telephones, and 25 pair cable connections. Now, this is you're the second group or the first group, whichever group you are, 1, 3, and 5. And the next time we see each other, which I think is going to be tomorrow, then you're going to get the in-person class with the first part, which is already on YouTube because I did that with the group 2, 4, and 6. Sections 2, 4, and 6. This way, all the first and second parts of the week are going to be posted on YouTube, so you can view them for your convenience. All right, that's it, and I will see you when I see you. Thank you for your attention, and well, have a wonderful day.
Have a good one.
Thank you. How do I stop this thing here? Stop share.